Hello, my name's Jack, and today I'll be comparing traditional and inquiry-based science teaching using the moon phase as a lesson. And I'll show how research, constructivism, and culturally responsive teaching help all students succeed. In a traditional science classroom, the teacher is the main source of information. The teacher explains the facts first, and students listen, take notes, and practice. In Miss Sheridan's class, she tells students the names of the moon phases, explains why they happen, and then has students use balls and flashlights to copy what she already showed them. This approach is clear and organized, but students mostly follow directions instead of figuring things out themselves. In an inquiry-based or discovery classroom, students learn by asking questions, exploring, and building their own understanding. In Miss Lee's class, students observe the moon for a month, ask why it changes shape, and then use models to test their ideas. The teacher guides them, but the students do the thinking. This matches research showing that students learn science best when they actively investigate and explain ideas instead of memorizing facts. That was a quote from Schwartz et al. 2017. Research shows that all students learn science better when they are actively involved, talking about their ideas, and using hands-on models. This is especially important for students with exceptionalities, such as learning disabilities or language differences. When students can touch, see, and discuss science ideas, they understand them more deeply. Vygotsky explains that learning happens through social interaction and support from others, which helps every learner succeed. Universal design for learning also shows that giving students multiple ways to learn show understanding and staying engaged helps all students access science, not just a few. Constructivism is the idea that students build knowledge in their own minds based on experiences. They do not just receive facts from a teacher. Instead, they connect new ideas to what they already know. Inquiry-based teaching fits this perfectly because students explore, test ideas, and revise their thinking. In Miss Lee's class, students use observations and models to construct their own explanation for moon phases. This is exactly what constructivist theory describes: learning by doing, thinking, and reflecting. Traditional teaching is efficient and clear, but it can leave some students behind if they do not learn well by listening and memorizing. Inquiry-based teaching is more inclusive because it gives students many ways to learn: talking, moving, drawing, modeling, and explaining. Research shows that using science practices like modeling and explanation helps more students succeed, including students with disabilities and English learners. Inclusivity is strongest when students feel their ideas matter and they are supported in building understanding. Culturally responsive teaching means valuing who students are and where they come from. In a traditional classroom, this might look like using examples from students' lives and being aware of personal biases when explaining science. In an inquiry classroom, it goes even deeper. Students' identities, languages, and experiences shape the questions they ask and the explanations they build. When teachers honor students' cultures and strengths, students feel respected and are more willing to participate. This improves learning for everyone and helps close achievement gaps. As a future science teacher, I will use inquiry and discovery by letting students ask questions, collect evidence, and build explanations. I will still provide structure, but I will guide instead of tell. I will use hands-on models, group discussions, and real-world connections so every student can succeed. By combining inquiry and constructivism, I can create a classroom where all students feel included, capable, and excited to learn science.